My roving field correspondent, Josephine, is standing by. Josephine?
Yeah, the hallways are getting kind of packed, so I convinced Danny Digg to join me here in the hood room. Danny Digg of Oregon State University, welcome. Nice name.
Thank you very much for inviting me.
I read that your specialty is in enabling programmers. What has changed in the world of computing that they need enabling?
Yeah, so my research is enabling programmers to confidently and to safely change very large computer programs out there. So I'm turning regular average programmers into Uber programmers who can change very large software systems. And the only software systems who are successful out there in the real world are those who keep changing. If a software system doesn't change, then it becomes obsolete, and no users want to use obsolete systems.
Uber programmers, I like that a lot. And the whole world is getting bigger, and bigger data sets are everywhere.
Mm-hmm.
So can you give an example of how automated changes in these large data sets, are used in the real world?
Yeah, so my research group has been automating a few kinds of these software changes, so I can give you a few examples. We've been working in the last few years to semi-automate, with the help of the program, this is an interactive automation process, to semi-automate programs to make them more efficient, to make them use a parallelism that is in every computing device, in laptops, in desktops, in mobiles. So all of these devices have now multiple brains. We call them multi-core processing. Mm-hmm. The software doesn't know how to use multiple brains, so then the software doesn't get any faster. So that's what I've been researching on the last few years. How can we adapt our software to actually effectively make use of the parallelism in hardware and to actually improve the performance of software.
Well, speaking of mobile phones, for example, people are using these phones to do more and more. They surf the web, they call up video, etc. And sometimes it's pretty slow. And you're saying that these automatic changes can actually make things faster?
Yeah, so recently we started looking at the specific domain of mobiles. So mobiles, smartphones and all these mobile devices are they have much limited computing resources than their bigger cousins, the desktops and the laptops.
Right. That's why they crash sometimes.
Yeah. Yet what you see, the usage of the model of the usage is
going
that people are switching to them and moving away from desktop and laptops, and most of the usage out of these devices is going to the network, fetching content from the web, loading a page or loading dynamic content that can take a long time. So if you are a programmer, you are not careful on how you program this, you can execute a lot of these network or services. You can execute them on the main, what we call the main user interface event thread, which will block the user interface, and your app will become unresponsive and you get very frustrated. And this is what causes people to write bad reviews about apps and to uninstall the app, and we've been helping programmers, enabling programmers to improve the responsiveness of their
We've all had that happen, so thank goodness that you are improving that. And the thing is, your work, if successful, is actually invisible to the end user. That's the point, isn't it?
That's the sign of a success. When computer science is truly successful, when it's not on the first page of New York Times, but when everybody's using it, it's like becomes the water and the air that we breathe. It's unnoticeable. Everything goes so smooth. Everything is so responsive. It's so
That's
interactive.
when it's good news for you.
Yeah.
Thank you so much, Danny. That was great work, by the way. Back to you, Chris.